Okay.
Good morning, students. So today I am going to take a class on polarization, which comes under BSc second sem. As I written on the board, it is BSc second year. It is BSc fourth sem. The title of the chapter is polarization. So we already studied what do you mean by polarization. Diffraction and interference. So interference, diffraction and polarization, these are all comes under optical physics. We know we divide physics into two groups, geometrical optics and physical optics. So geometrical optics is one which explains that the light will travel in a straight line. So reflection and refraction and the rectilinear propagation of light can be defined on the basis of geometrical optics. Where another one, second type, is called physical optics. So physical optics is one where the light travel in the form of waves. The energy, light energy, travel from one point to the another point through wave. It's called the physical optics. Under physical optics, we have to study. You already studied interference, diffraction in the class. So this is the third one, that is polarization. So first let me explain what is the difference between interference, diffraction and polarization. See, they have their own definition, interference and diffraction. So there in the case of interference and diffraction, we cannot notice whether the type of wave, whether it is transverse or longitudinal. So where with the help of this polarization only we can explain, we can define whether the light is linearly polarized or longitudinally polarized, longitudinal wave or transverse wave. So where in the two cases, before these two phenomena, I can say these two are the phenomena, interference and diffraction, there we could not notice whether this is longitudinal or transverse. Where in the case of the polarization only, we could be able to understand whether the light is longitudinal or transverse. This is the only phenomena we could notice, can find out the nature of light, transverse and longitudinal. Where we could not notice with the help of two phenomena, they are interference and diffraction. This is the only phenomena of light where we could be able to explain on the basis of optical physics. Okay. So this is polarization, what I told you just now. So we had different experimental methods in your previous class, that's in second year PUC. We had that information in that course second year PUC. So using tourmaline crystal you can find out the polarization phenomena. So polarization is the one-sidedness. So it is the point in which the light will travel through the straight line. So it will not give any oscillations. So this is polarization. So once we understood what we mean by polarization, then we should know the methods to produce polarization. There are four methods. They are, first one, by the method of reflection. By the method of reflection. By the method of diffraction. By the method of double refraction, by the method of selective observation. Selective observation. There are four methods. They are from four methods we can produce polarization, plain polarized light. I can say first one is reflection, from the method of reflection. Second, from the method of refraction, and third, double refraction, and fourth one is selective absorption. So, first from the method of reflection, so we can produce polarized light that we can study with the help of Brewster's law. So, with the help of Brewster's angle, that is Brewster's law, we can easily define mu is equal to tan theta p. Theta p is the polarized angle. So, this is the first method, experimental method, from the method of reflection. The next from the method of refraction. So through refraction also can produce plane polarized light. And then third one, double refraction. So double refraction, it means by passing the light, unpolarized light through the calcite or quartz, so we can produce two rays. Ray 1 ordinary, ray 2 is extraordinary. From these two we can find out this is we can produce plane polarized light. So third one, last one, selective absorption. So some of the medium, so that will absorb one type of radiation, maybe ordinary, and it will allow only another type, it's called extraordinary. So by using particular crystal, we can produce plane polarized light by the method of selective absorption. So next, double refraction and refraction and refraction. So after knowing what you mean by plane polarized light and what are the methods we can produce plane polarized light, let me know next. It is very important to know what you mean by optic axis. So optic axis, as I shown here on the board, so this is a figure I can able to show the figure. So this is a crystal, maybe this is a cubic crystal. So this is first we have to see the corners. So A, B, C, D, E, F, G, H. What I written on the board, what I drawn on the board with the help of this figure. So this is the cubic structure. So here, so there is a slightly difference. It's not 90 degree. The angle should not be 90. For the cube, it may be 90. It is not similar to the cubic crystal. So here, you have to choose two corners. You have to choose two corners and join these two corners. For example, if you look at the board, we have two corners A and H. If you join the line through A and it passes through H also. So this line, these two corners A and H, these two corners, they are called blunt corners. They are called blunt corner. So blunt corner is one, the angle should be obtuse, greater than 90 degrees. They are called blunt corners. If you look at the figure, I written angle 180 degree. It is blunt corner. And also the corner H, it is also angle. If I see the angle, it is also 120 degrees. So it should be greater than 120. If I join these two opposite corners, so this line is called the optic axis. Optic axis, it is not the line, it is the direction of light. So it is very important now to explain ordinary ray and extraordinary ray, so which comes under polarization. So this is about the optic axis. After knowing optic axis, and so let me we have to choose one method, that is by the method of double refraction, so we can produce polarized light. So for example, so I will remove this figure. We don't want this, I think, this time. So this is calcite. This is calcite. Calcite is the doubly refractive medium. So if I send a light passing through this calcite or quartz, so it splits into two rays. So one is ordinary ray, another one is extraordinary ray. So these two rays, ordinary and extraordinary, these two rays are plane polarized light. So here, and these two vibrations are mutually perpendicular. If the ordinary is parallel to the board and extraordinary is perpendicular to the board. So I can show it on the figure as the parallel line, it is parallel to the board, extraordinary, and I can show it by some dots, putting the dot. So dot indicates the waves are perpendicular to the board and the line indicates parallel to the board. It is noted that these two waves are mutually perpendicular and these two are plane polarized light. Okay. So here, so we have to take the crystal of quartz or calcite. Then only this is called the, from the method of double refraction, you can produce polarized light. particularly usually plane polarized light. So this is on this basis. So Hyacinth's theory of positive and negative crystals. So as explained by Hyacinth, so he is trying to explain what I mean by positive and negative crystals. So here I have drawn two figures. It is very important figures are I drawn here. So here, so in first figure, so this is the quartz. You have to take the quartz crystal. This is the negative crystal. This is the negative crystal. This is the quartz. Quartz and so here I written here calcite and quartz. These two are the two crystals which can produce plane polarized light, which is ordinary and extraordinary. So here, according to Hyacinth, so S is the point source. From the point source, the waves are emitting in all the directions. So here, so this is the quartz. So I told you, so through the crystal, if the light travels, it splits into two rays, ordinary and extraordinary. So I shown here in the board. So it is shown here. This is the extraordinary ray. I written here extraordinary ray, and I written another ray, that is dotted. I shown dotted. This is called the ordinary ray. So here the waves are the velocity. If you see the light direction, you can say that. So the velocity is not constant. So here, see along the optic axis, only it remains constant. So this is the point. So this is the point. So if you come to another side, the waves, I mean these waves, this is ordinary wave surface. This is extraordinary wave surface. So this is extraordinary wave surface. It is here, dotted line, which is, I can show it here. This is extraordinary. This is also extraordinary. So here, so this is, it is, see, so it is common. It is common. It is, the line is common for elliptical shape as well as circular shape. So circular shape is one where the ordinary ray. So the velocity is constant everywhere. So if you find the vibrations of the particle, and if you join all the particles at one time, you will get the ordinary wavelength. So it's called the radius is constant in all the directions. Where for the extraordinary ray, it is, the velocity is not constant, so it is same along the optic axis with the that is ordinary ray, where if you come to the perpendicular to the optic axis, if you join all the wavelengths, you will not get the circle, you will get the elliptical shape. So if you see this, so inside the circle we have the elliptical shape. In the case of the quartz crystal, it is where the refractive index of extraordinary should be greater than the refractive index of ordinary. Refractive index of ordinary less than the refractive index of extraordinary. And this is another one. If you come to the same figure, next slide, this is another figure. I can show here on the board. So this is refractive index of ordinary is greater than refractive index of extraordinary. So here, so this is if you see the circle, so this is where the velocity is common along the optic axis. I shown it here on the board. Optic axis, along the optic axis, the velocity is common for ordinary and extraordinary. It is common for positive crystal as well as negative crystal. So here, so if you see the velocity of extraordinary, in the case of that is negative crystal, it is in the shape of elliptical shape. So here, elliptical shape of extraordinary is outside the circle, where here in this case, it is elliptical shape is within the circle. It is very important to note here. And this is optic axis is very important here. So along the optic axis, both are vibrating with the same velocity. It is also in the same velocity, where elliptical shape it is outside the circle. Here the electrical shape is within the circle. Okay, then this is called positive crystal. Yes, I'm sorry. This is called the positive crystal, and this is the quartz. Positive crystal is called the quartz, and this is the negative crystal. This is called the calcium crystal. So next one is important to note that how to identify ordinary and extraordinary. So if you mark a point with the help of take a white paper and mark a point on the board of the paper and place it the calcite of quartz will appear two points. How to identify whether this is ordinary and extraordinary? Then what should we do? We have to rotate clockwise or anti-clockwise this crystal. Then one ray is oscillating fastly. It vibrates fastly. It changes its position rapidly. Where another one will not change its position rapidly. So which is not changes, it's called the ordinary ray. The point which will rapidly changes, it's called the extraordinary. So here, what do you mean by ordinary? Ordinary means which obeys the law of refraction. Mu is equal to sin I by sin R. Which ray obeys the law of refraction? Snell's law, it is called the ordinary ray. The ray which will not obey the law of refraction, it is called the extraordinary ray. But extraordinary ray is also polarized light. Ordinary ray is also polarized light. So this is about the class I taken in part 1, that I mean under the polarization for the 4th sem, BSc 4th sem. So what we studied now, so this is in the examination, so they will ask what do you mean by polarization and for which purpose it is used for. So it is used to notice or find out whether the wave is transverse or longitudinal. This is the only method where from the method of interference or diffraction we could not find whether this is longitudinal or transverse. So this is one-sidedness. You will have one-sidedness. So there are 4 methods as I told you. In examination they will ask you to write 4 methods. They are reflection, refraction, selective absorption and double refraction. So double refraction is important here. I told you with the help of the double refraction. So this is where I explained what I mean by ordinary and extraordinary, which obeys the law of refraction, ordinary which does not obey the law of refraction, and both are plane polarized light. And ordinary perpendicular to the board, it vibrates. Extraordinary, it is parallel to vibrates, parallel to the board. And this is very important. It is for 5 marks. This is 5-mark question. It will ask in the examination, very important. Ions weighted of positive and negative crystals. And they will ask you and give an example for positive crystal. You have to write the quartz, and for the negative crystal, it should be calcite. And so this is inside the circle we have the electrical shape, and outside the circle we have the electrical shape. But I shown here dot is perpendicular to the board and the lines are parallel to the board. Okay. So this is a very important topic, and with this I conclude this class. Maybe part 1, and in part 2 maybe the next of this polarization I will engage in the next class.